Hello and welcome to today's episode of how I build my Doll 362 steam engine replica. Today we'll deal with the entire crankshaft assembly, starting of course with the crankshaft itself. We'll machine it from this piece of rod between centers. You see I have the dog mounted already. I prepared this to length and center drilled it a while back, which was insanely stupid in hindsight because if I wreck the threads on the end, then I have nowhere to start over. But we'll make it count on the first try. I'm pretty sure that's going to work. We'll also have to modify the flywheel a bit, but more on that later. First of all, let's get the crankshaft done. Okie dokie. Bearing blocks are in place, and as you can see, it spins nice and freely without any play. I've got a bit of side play in here, probably 0.5 millimeter. We can always take that out with spacers later on if we want to, and I'm probably going to reduce the side play alone by mounting the eccentrics and pulleys here. Now these guys I bought already. We'll have to do some little modifications to them. For example, this is going to be the power takeoff pulley. It's going to get face down on this boss here to a thickness of 5 millimeter, which basically leaves the entire rim here intact. This one also gets face down to 5, and then we'll drill it and ream it 1/4 inch, just like this one here as well. This one will also get a hole for a set screw drilled and tapped. The drill will of course want to follow the hole that's already in there, but still I wanted to take no chances and get this thing running as true as possible, so I used the 4-jaw for this job. Alright, crankshaft installed, the pulleys are on here and the flywheel as well. You can see it wobbles a little bit, which is, well, kind of what I feared because I re-engineered things here and then I re-engineered them. When you take a look at the drawing here, you can see that what I just turned in the lathe was absolutely not what is here. The one I made actually has one extra boss here, 5 millimeter diameter, for the bushings. Now on this one it's all 1/4 inch all the way around. For some reason I made the bushings in the bearing blocks 5 millimeter, which wasn't necessary. You see, my plan initially was to have this entirely 1/4 inch, the bearings 1/4 inch, so that if wanted I could also take this shaft out the side without taking the bearing blocks off. So yeah, I made a new shaft here, not only because I was unhappy with the run out on the flywheel, but mostly of course due to the fact that it was not according to the drawing. And you can see now the flywheel run out is a big lot less. You can actually see that the casting itself, which is not machined, is running out a bit on the backside. Nothing I can do about that, but now as you can see I made new bushings which are 6 millimeter and runs just as freely as before, but now I can loosen the set screws on the flywheel and the pulleys and slide the shaft out without having to take the bearing blocks away. Taking a look at the ends of the shafts here, you can see that I didn't thread either end. That's because I rethought a little bit and I think I want to try at least and cross pin both cranks onto here like on the original. It might not work, that's why I'm going to try it on a dummy shaft first. If it doesn't work, there's still enough meat here to put thread on here as initially planned. Next up are the crank web and the eccentric. On the original, the design would have been a little different. The eccentric would have had a round slot cut into it, which then the pin that we're going to drive into the crank web would engage into, and that would enable this machine to run in forward and reverse. Now, milling a key slot round like that isn't possible in my machine shop because I don't have one of these cranky rotaty thingies, and I also don't have a milling cutter small enough. So yeah, we're going to make this thing straight hole, straight pin, and no lollygag, and it's just going to run in one direction. To me, it's not that big a deal. I run my machines in one direction only most of the time anyway, so that's how it's going to be. Now, parting straight through that thing on my lathe with the off-center hole there would be absolute suicide. So what I did was come up right to the hole with the tool and finish it off with a hacksaw and then clean that surface up on the little Emco lathe. When we spin this thing up, it looks actually quite mesmerizing. I did notice that I actually need 3 eccentrics, so I had the whole fun again and made me the 3rd. You know, one's for driving the water pump. Here are both the cranks. I'll polish them up a bit more when I'm completely done with them. They're nice, tight and play-free push fit on here, which I really like. And I don't know if I've said it before, but this is really starting to look like a steam engine. The way that these cranks are fitted onto the shaft rose quite a bit of controversy when I initially made the design drawings, because from the pictures I had, it looked as if they were pinned onto the shaft with like a taper pin, and I was really uncomfortable with that because you would have to, number one, drill such a tiny pinhole through here. Number two, you would have a blind hole which you would then have to taper ream. And number three, you would drill a 1 or 2 millimeter hole right through this shaft. This is only 3 millimeters thick, so it would weaken the shaft a whole lot. And remember, this is where all the piston force goes on to later. So I had a deeper look into the internet, and luckily I found out that it's actually held on with a grop screw on the originals. So that's exactly what we're going to do. The only difference I make is, instead of having threaded ends here, I'm going to go with a plain shaft, no threads, because I don't really like the idea of squishing onto those threads with the grub screw. And you know, this is a nice play-free fit on here, and I think with some Loctite it's just never going to go loose ever again. Drilling these holes was nowhere near as simple as I made you think. Off screen I spent plenty of time with the center punch and making a small dent, then putting it all on the shaft, looking, comparing the position of the pin and the position of the dent I made, readjusting and so on and so forth. And now I've got it so that we can put these two guys here together. Now of course these guys don't only have to fit together with each other, but also their bores now have to be concentric so that we can put this onto here, and I'm happy to say that they're going on here nice and tightly and still able to rotate on here, but once we snug this guy here down, everything is nice and solid. First comes the water pump eccentric. Now I don't have any grub screws yet, as I said, so but this is a rather tight fit on here. Nevertheless, so we leave it like that for the moment until we get the grub screws. Same goes for the cranks here. They will of course not remain like that. I plan to use pointy grub screws on this one and drill a tiny divot into the shaft to just make sure that the cranks will never move on the crankshaft. And here are the two little crank pins. Well, that concludes this part of the build. The crankshaft is complete. I'll add the little grub screw here later. And if you didn't notice yet, I also replaced these grub screws with proper slotted head screws like on the original. Just looks a lot nicer now. On the original, this would have all been brass. And I deliberately decided against that because there's quite a lot of force going onto here. I mean, the full piston force is pressing right against here, and I've had two steam engines where the thread on either the crank pin or the crankshaft had simply worn out after 90 years, that is, of course, but still, it's a weak point that I know how to get rid of, and that's by doing this. The other reason I made this out of steel is because on the original, if I had it brass, I would have of course needed to nickel plate all this, and then all my fits would have gone away. Like for example the eccentric on the crankshaft, the crank pin in the crank, and so on and so forth. This way I'm skipping all of that and don't need to worry about any close tolerances. Now, instead of nickel plating, I think it would look kinda cool to blue the screws. Not blue as in make them black like this one, but heat them up until the color changes into a blue. Let me know what you think about that. I'm not committed to it yet, but any opinions here are greatly appreciated. Thank you very much for watching. That's it for this part. Bye bye!